Hi. Now I am going to discuss with you that is a special topic in +1 chapter redox reaction, that is oxidation number. Oxidation number means it is charge of an atom in elements, compounds, ions like that. Simply it is oxidation number means charge of atom in element, compound or ions, etc. Now I am going to explain some special cases of oxidation number. Number 1, if calculated oxidation number have higher value than its maximum oxidation number. If we get a calculated oxidation number which is higher than its maximum value. Example number 1, H2SO5. It names Carus acid. Okay. Generally by calculation, hydrogen have +1. There are 2 hydrogen, so +2. Sulfur unknown. I give X. Oxygen have oxidation number -2. There are 5. -10 equal to 0. By calculation, X equal to +8. Is it possible? No. Sulfur have maximum oxidation number +6. So, if you get a calculated oxidation number higher than its maximum value, it is wrong answer and you should assign this higher value. So, in H2SO5, sulfur have oxidation number +6 only. It can explain by its structure. H2SO5 structure is sulfur, 2 oxygen here, 1 oxygen, 1 oxygen, another oxygen here and hydrogen, here 1 hydrogen. This hydrogen have +1 oxidation number, this hydrogen have +1 oxidation number. This oxygen -2, this oxygen -2. Listen, there are oxygen-oxygen bond. It is known as peroxide bond. In this peroxide bond, these 2 oxygen gets -1 and -1 only. So we can simply say that this sulfur have +6 only. In H2SO5, sulfur have +6 charge. H2SO5 contain 1 peroxide bond. This oxygen-oxygen bond is known as peroxide bond. Another example, H2S2O8. It names Marshall's acid, H2S2O8. By calculation, this sulfur get +7 oxidation number. Is it possible? No. We should assign its highest oxidation number +6. H2S2O8 have a structure S double bond O, double bond O. Here 1 oxygen, here 1 oxygen. Another sulfur, double bond O, double bond O. Here 1 oxygen, here 1 oxygen. Then hydrogen, then hydrogen. This OO bond is known as peroxide bond. Again, there is peroxide bond. These 2 oxygen have charge -1, -1 only. Then this sulfur get +6, this sulfur get +6. So, if we get a calculated oxidation number higher than its maximum value, we should assign its highest oxidation number only. I am going to explain another example, CrO5. It is known as blue perchromate. Blue perchromate. By calculation, this Cr gets plus 10 charge. It is not possible. Chromium have highest oxidation state plus 6. So in CrO5, oxidation number of chromium is plus 6. This structure can be like this. This structure is known as butterfly structure. This OO bond is peroxide bond. Here another peroxide bond. This oxygen minus 1, this oxygen minus 1, minus 1, minus 1. Total, this chromium have plus 6 because this oxygen minus 2. So, in these cases, we can finalize that if we get a calculated oxidation number higher than its maximum value, we should assign its highest oxidation number only. Okay, now I am going to discuss about the fractional oxidation number. If we get a calculated oxidation number is fractional, we have to show that it is not its actual oxidation number, but it is only its average oxidation number. What is the meaning? If we get a calculated oxidation number is fractional number, it is not its actual oxidation number, it is only its average oxidation number. If calculated oxidation number is fractional, it is not actual oxidation number but only average oxidation. Okay, let's go through examples. Example number 1, C3O2. It names carbon suboxide. If we calculate oxidation number of carbon, we get only plus 4 by 3. Plus 4 by 3 oxidation number cannot be possible. It is only its average oxidation number. I am explaining oxidation number by this structure. This oxygen minus 2, this oxygen minus 2. This carbon plus 2, this carbon plus 2, this carbon 0. 3 carbon have charge plus 4. What will be its average? It should be plus 4 by 2. If we get a calculated oxidation number fractional value, it is not its actual oxidation number, it is only average oxidation number. Actual oxidation number can be calculated by the structure or by composition like that. Example number 1, C3O2. Another one, Br3O8. By calculation, Br gets charge plus 16 by 3. I am going to calculate oxidation number, actual values of this bromine. First bromine, second bromine and third bromine. Double bond, oxygen, double bond, oxygen, double bond, oxygen 2. Okay, all oxygen have minus 2, minus 2, minus 2, minus 2. What about this bromine? Plus 6. Similarly, minus 2, minus 2, minus 2. This plus 6, minus 2, minus 2. This have plus 4 only. You can sum the values, plus 6 plus 4 plus 6, total 16. By calculating the average, it is 16 by 3. So what is the actual oxidation number? 2 bromine have plus 6 and 1 bromine have plus 4. I am discussing another example, that is Fe3O4. Fe3O4. By calculation, Fe get the charge plus 8 by 3. It is only its average value. This Fe3O4 is the combination of two compounds, FeO and Fe2O3. In FeO, Fe have the charge plus 2. In Fe2O3, Fe have the charge plus 3. So, we can sum the value plus 3 into 2, plus 6, plus 2, plus 8, total plus 8. Average value plus 8 by 3. So, what is the correct answer? 2 Fe have plus 3 and 1 Fe have plus 2. I am explaining one more example. S4 O6 2 minus. S4 O6 2 minus. By calculation, what will be the charge? Sulfur, 4 sulfur and 6 oxygen. The value will be, by calculation, 4x, 6 oxygen minus 12 equal to minus 2, 4x equal to 10, x equal to 10 by 4. 10 by 4 is only its average value. I am going to calculate its actual oxidation number by the structure. Sulfur. How many oxygen? 6 oxygen. That is 2 oxygen double bond and 1 oxygen single bond. 2 oxygen double bond and 1 oxygen single bond. The single bond is due to the charge 2 minus. 1 minus here, 1 minus here. So, there is no need of 2 bond for these 2 oxygen. What will be the charge? Oxygen minus 2, oxygen minus 2, oxygen minus 1. This sulfur have plus 5. Similarly, this sulfur have plus 5. These 2 sulfur have 0. By summing the value, we get plus 10. Average value plus 10 by 4. So, this is about the fractional oxidation number. If we get fractional oxidation number by calculation, it is not its actual oxidation number, it is only its average value. Its actual oxidation number can be calculated from the structure or composition like that. Okay. Now I am going to explain oxidation number involving coordinate bond. We know about the coordinate bond. A have lone pair, B have vacant orbital. This lone pair donate to B and undergo share. This type of bond is known as coordinate bond. Here A is donor, B is acceptor. If a chemical compound contains this type of bond, how oxidation number can be calculated? Okay, if containing donor atom and acceptor atom, we have to focus a special point. If donor have higher electronegativity than acceptor. If donor have higher electronegativity than acceptor, you should know no change in oxidation number due to this coordinate bond. What it is? If donor have higher oxidation, higher electronegativity than acceptor, no change in oxidation number by coordinate bond. In other case means both have same electronegativity, or acceptor have higher electronegativity than A. First case, donor have higher electronegativity. In other case means both have same oxidation number, or acceptor have higher electronegativity. In this case, donor gets plus 2 and acceptor gets minus 2. This is the point we have to note. If donor have a higher electronegativity than acceptor, no change in oxidation number by coordinator bond. In other case, that means both have same electronegativity or acceptor have higher electronegativity. In this case, donor gets +2, acceptor gets -2. Let's go through example. Number 1. HNC. We know it is isocyanide. Isocyanide. Its structure is HN triple bond C. In this, one bond is coordinator bond and donor is nitrogen. First, I am leaving that coordinator bond without considering coordinator bond. Hydrogen and nitrogen. Hydrogen have high electronegativity +1. Nitrogen and carbon. Nitrogen have high electronegativity, so -3. 1 here, 2 from here. What about carbon? Its oxidation number -2. Then we have to check this coordinator bond change oxidation number of nitrogen and carbon. There is no case. Nitrogen and carbon in this coordinate bond, nitrogen is donor. Nitrogen is donor, and this donor have a higher electronegativity than acceptor. So what is the meaning? This coordinate bond do not change oxidation number of nitrogen and carbon. Okay? If donor atom have a higher electronegativity than acceptor, coordinate bond do not make any change in oxidation number. Let's consider another example. S2O3 2-. S2O3 2-. Okay. Sulfur, double bond oxygen, single bond oxygen, single bond oxygen. There are 2-, so 2 oxygen make a single bond only. This sulfur have 1 lone pair. That lone pair donate to another sulfur to make coordinator bond. This is the structure of S2O3 2-. First, I am considering only covalent bond. This oxygen -1, this oxygen -1, this oxygen -2. Then what will be the charge of this sulfur? That is +4. Okay. Then I am going to consider its coordinator bond. Both are sulfur. Sulfur is donor atom. In this case, coordinator bond changes oxidation number. Donor gets +2, acceptor gets -2. Already sulfur have +4, that become +6. This is acceptor, it get -2. So in this case, one sulfur have +6 and another sulfur have -2. So by these two examples, we have to focus the point based on electronegativity of donor atom and acceptor atom, effect of coordinator bond can be explained. Thank you. Another type question, that is same atoms with a different oxidation number. Okay, in a compound there are same type atoms, they have different oxidation number. That is one important example is CaOCl2. CaOCl2, it is one part of our bleaching powder, we know. In CaOCl2, it is actually Ca2 plus and Cl minus and OCl minus. CaOCl2 is actually Ca2 plus and Cl minus OCl minus. From this Cl minus, chlorine have -1 charge. In OCl minus, chlorine have +1 charge. So in CaOCl2 there are 2 chlorine, but one chlorine have -1, another chlorine have +1. This type example, I already explained S2O3 2 minus. What will be? One sulfur have plus 6 and another sulfur have minus 2. One sulfur have plus 6, another sulfur have minus 2. I already explained by the structure. This one. By the structure, one sulfur have plus 6 and another sulfur have minus 2. You get one example like that. NH4NO3. Very simple. In NH4NO3, this NH4 have plus 1 charge and NO3 have minus 1 charge. So, I am splitting NH4 plus and NO3 minus. In NH4 plus, nitrogen have minus 3. In NO3 minus, nitrogen have plus 3. So, in this type of compounds, same atoms have different oxidation. Okay. Now, I am going to discuss oxidation number of carbon in organic compounds. Some compounds are very simple, very easy. Example, CH4. By considering electronegativity, we can explain the oxidation number. Hydrogen have plus 1. So, there are 4 hydrogen, carbon gets minus 1. Number 2, CH3Cl. What will be? Hydrogen plus 1, there are 3, plus 3, minus 1. So, plus 3 minus 1 plus 2, this carbon gets minus 2. CH2Cl2. What will be? Hydrogen plus 1, chlorine minus 1, this carbon 0. CHCl3. Hydrogen plus 1, chlorine minus 1, so this carbon gets plus 2. And finally, CCl4. Chlorine minus 1, so this carbon plus 1. These are simple questions. Oxidation number of carbon in organic compounds. Here, I am considering some another questions. Number 1, CH3CH2OH. Here, there are 2 carbon. CH3CH2OH, there are 2 carbon. Both carbon have different atmosphere, different surrounding atoms. So, oxidation number of both carbon may same or different. In this case, from organic chemistry, we are studying that CH3 is electron donating group. CH3 is electron donating group. So, this CH3 should assign a plus 1 charge. So, this CH2OH should assign minus 1 charge. In this calculation, CH3 have plus 1, CH2OH have minus 1. Then we can simply calculate the oxidation number of both carbon. How? In first question, carbon X. There are 3 hydrogen plus 3 equal to total charge plus 1. Then X equal to minus 2. Second question, again carbon X. There are 3 hydrogen plus 3, oxygen minus 2, total charge minus 1. By calculation, X will be minus 2 plus 3, what will be plus 1? That plus 1 go there, minus 1 plus 1, 0. Okay, in CH3, CH2OH, this carbon have minus 2, this carbon have 0. Let's take one more example. CH3COOH. First one, CH3. That get plus 1 charge because it is electron donating. COOH gets minus 1. This CH3 is already calculated, so there is no change here. There are 2 oxygen minus 4, hydrogen plus 1. Total charge minus 1. minus 4 plus 1 minus 3, minus 3 go there, minus 1 and plus 3, x get plus 2. So in these questions we should assign a plus 1 charge for CH3. Why? CH3 group is electron donate.